So after a bunch of requests from you guys at school. Alrighty, so we're going to be solving integrals via substitution. There are two types of integrals we would be solving for. As you know, there are indefinite integrals and definite integrals. So we're going to be looking at both of them today, and we're going to be following 8 steps in order to solve indefinite integrals. So let's jump right into it. So let's look at this integral right here, and let's apply these steps in order to solve the integral. So here we have the integral of radical 2z minus 1. Alright, and typically what we would do to solve an integral would be to find the antiderivative inside the integral. But for many cases, we won't be able to just quickly solve or quickly know what the antiderivative is, right? So in that case, we would have to use substitution. And substitution is very convenient because it allows you to take a whole expression, as you'll see in the video, and turn it into one variable. And with one variable, it's easier to work with, alright? So let's take a look at this, and let's follow step 1. So step 1 says, look at the equation, right? So I'm looking at the equation. Whatever's inside a grouping symbol is your safest bet to take substitute, alright? So that means that, well, in this case, my grouping symbol is, we have a radical, we have just parentheses, we have 1 over parentheses, we have an exponent, x to the squared, or we have ln x, right? Well, in this case, our grouping symbol is a radical. So we're most likely going to be taking 2z minus 1 and substituting it, and I'll show you what I mean in step 2. So the way we substitute is we let a variable, in this case we typically use u, let u equal the expression. What expression are we taking from that grouping symbol? Well, it's 2z minus 1. Alright, cool. So let's move on to step 3. Find the derivative of u, aka the expression. So here we're going to completely disregard this side, right? We're only looking at this side. We're not looking at the integral. We're taking the derivative of u, alright? In this case, u equals 2z minus 1. So in order to take the derivative, and this is in respect to z. So we're going to be taking the derivative of du over dz. So in this case, we can use the power rule to find the derivative of 2z minus 1. In this case, it's just 2. Right? Because then this is 1, this goes 1 in front, and it turns into a 0, and the constant's derivative is just 0, nothing. Cool. Now we're going to solve for du. So du, again, is a quantity. We're treating it as a quantity. So we're going to solve for du. Well, we need to multiply both sides by dz. And so du equals 2 dz. So we solve for du. Now we have to solve for the common factor. What I mean by common factor is we're substituting, essentially. We're going to take du and we're going to put it into this integral because we have a variable u. And in order to integrate, the derivative has to be in terms of u. Alright? So in this case, what's the common factor? Well, I don't see a 2 dz here. I only see a dz. So that means that our common factor here is just dz. So that means that we have to take away this 2 from this side. And we have to move it here. So essentially we have half du equals dz. And now this is what we want. This is going to allow us to plug in or substitute dz for an expression with du because that's what we're essentially doing. Alright? So now we're going to substitute our variable. So instead of writing 2z minus 1, we're going to grab this variable and put u. And instead of putting dz, we know that dz is equal to 1/2 du. So we're just going to put times 1/2 du. And as you can see, we substituted here and we just literally plugged in what we had, substituted again. And we still have the integral sign, right? Now, what do we do here? Well, we know that anything times a constant, we can kick it out. And we can multiply at the end. So now we just have this simple integral. And that's something that we can solve. Alright? So with this, right, we can just simply use the antiderivative rule. U to the 1/2. And since we're integrating an indefinite integral, we must put plus c. And this is all multiplied by 1/2. Alright? And in order to do that, well, we'll just distribute. So we'll have 1/2, so these cancel out. And 1/2 times c, we know that c is our arbitrary constant. Our arbitrary constant is essentially just any number. So what we'll do is, we'll just leave it at c. So this actually turns into u to the 3/2 over 3 plus c. And the last step now is to substitute with expression. So we're going to substitute our expression, what we had originally subbed in for. So what we're going to do is we're going to put 2z minus 1 instead of u. We're just plugging in the original expression. And we are taking that to the 3/2 power over 3 plus c. And now this is your evaluated integral. So now that we know how to solve indefinite integrals via substitution, we're going to talk about how to solve integrals that are definite. Alright, so we're going to use basically the same rules, except these last steps change a little bit. And we're going to see how that plays out in this example. Alright, so this is the integral. So this is a definite integral, so it has limits of integration. So it has from 0 to 7, find the integral of 1 over, or dx over x plus 2. Alright, so now we're going to look at the equation. What grouping symbol are we using? Well, this is a fraction bar. So our substitution is basically going to kind of have to do something with this 1 over x plus 2. Alright, I'm just rewriting it just so it's very clear that this is what we're going to be substituting. So let's substitute it. So we're going to let u, right, we're going to let u equal x plus 2. Now what do? So we disregard the sign. We find the derivative. As soon as you let u equal x plus 2, you find the derivative. So this is just 1. Alright, because we used the power rule. And now what do? We solve for du. So du is equal to dx. Perfect. So now what we have to do is, well, we substitute. So du is just dx. And now 1 over x plus 2, well, x plus 2 is u, so we can just do 1 over u. But I'm going to leave this integral alone for a while because something different happens with definite integrals. So since we have limits of integration, we're going to have to change that in order to find an exact answer. So how do we change that? Well, we have a relationship here. We know that for every u, we have to have an x plus 2. So what we're going to do is we're going to use this to change our limits of integration. So we're going to take 0, we're going to plug it in here. 0 plus 2 is 2, so the lower limit of integration is going to be 2 because we're using a new variable, which means that we have to change that. So this is going to be used to change this and this. So the top one would be 9. And now we just integrate. We literally just solve. Alright, so now what is the integral of 1 over u? Well, the antiderivative is going to be ln u. And since we have limits of integration, we're going to have 9 and 2 here. We're just using antiderivatives at this point because we know what 1 over u is. And now we just solve. Alright? And this could translate into ln of 9 over 2. And this is your answer. Either of these is correct. And really quickly, let me just reiterate, we don't need to substitute. Before we had to substitute the original equation back in here, but since we're solving a definite integral, it's an exact area. We're trying to find an area of a specific curve, and we're trying to find that exact area, so there's no need to plug in the equation we substituted. There's no need, because we already changed the limits of integration to fit with our new variable, which is u. Alright, so that's why we don't really need to substitute back in or anything, so we're fine. Alrighty guys, thank you so much for watching this video. If you guys really like, or if the tutorials really help, please make sure to let me know down in the comments below. Like this video if it helped you, or if this is what you were looking for. So yeah, stay cool.